We have a real big treat for you now. I would like to introduce you to a robot and to his human. I would like to introduce you to Heather Knight. Heather is currently conducting her doctoral research at Carnegie Mellon's Robotics Institute and is running Marilyn Monroe Robot Labs in NYC, which creates socially intelligent robot performances in sensor-based electric art. Founder of the Robot Film Festival and Cyborg Cabaret, Heather was on the 2011 Forbes list for 30 Under 30 in science. Ladies and gentlemen, please welcome Ginger, the robot, and his human, Heather Knight.
Hello, everyone. A lot of awesome demos today, and I snuck a humanoid into the conference. So I want you to imagine a world where we encounter robots so frequently, flying, legged, autonomous on our streets, that we constantly have to navigate human interfaces with these machines. For example, let's say you had one of your drones that wanted to attend the workshop on Sunday, because a drone workshop should be for both humans and robots, right? It has to fly perhaps through the park, go navigate down possibly crowded streets. It could go in the air, but once it gets to the revolving doors, how is it going to communicate to people that it wants to be the next one in line? Once it's in the elevator, where should it hover? I think about a world in which we have to design social interfaces with machines, and I take some of my inspiration for my research at Carnegie Mellon University from theater. So I'm going to start out with a robot performance, and then I'm going to tell you a little bit about robot body language so that you can design your paths and your trajectories for your machines, not just to not collide into things, but also to express its state and perhaps communicate with people.
Hello, everybody. Can you hear me? All right. The volume is good. Okay, thanks. Let's do this. I know what you're thinking. Who let the humanoid robot in the theater? Close your cameras, everyone. I'm gonna stop talking and try to fit in.
It's a drone!
What? I was just looking for the Jonas Brothers! Exclamation mark. Actually, I'm a robot comedian. I even do stand-up. Get it? Don't worry. Unlike with human comedians, it's okay to tell me when I'm bombing. No offense, guys. I'm kind of jealous of you flying robots. I just flew in from Pittsburgh yesterday. Airport security is so humiliating. They make me go through the X-ray machine with all my motors on display. I just try to erase the memories. Memories erased.
You have nothing to be shy about. You're looking pretty dapper. I love these new orange plates.
I'm on a low-voltage diet.
Yeah?
Yeah, I have really been amping it up.
Amping it up.
But I'm not just here to hit on the Predator drone. Or rage about Delta's customer service. It's terrible. My programmer, Heather Knight, is a researcher at Carnegie Mellon University. She specializes in robot, body, language, and social robotics. Drone designers. Do you want your machines to seem friendly or hardworking? Then, listen up. Do you want them to chase down your cheating boyfriend? You've got bigger problems. Okay, enough terrible jokes. I'm done. Heather, take it away.
All right, thank you, Data. But we are definitely not taking the Predator drone home with us.
But I already gave him my frequent flyer number.
Ching. All right. Awesome. Great. So assuming there are times when we don't want to just be doing awesome piloting maneuvers with our drone and we want to give them some autonomous intelligence, perhaps we should enable them with some capabilities to make friends and or scare people. So next slide. Let's see. I need a clicker. Right. So the big ideas in my talk is one, it is just the case that humans immediately judge machines. And neurologically, we process machine motions very similar to the way we process human or creature motion. So if we understand that, we can design really awesome and communicatory machines. So, have you seen the Terminator? Woo! All right, so his visor and Skynet enables him to determine who people in his environment are. Namely, are they friends, are they foes? It turns out we do the same things with robots. It's a lot like a job interview. As soon as someone walks into a room, we have a certain impression of how nervous they are through a handshake and how they're holding your hand. It can very much influence our sense of their confidence level, their experience. We make these same sort of first impressions with machines. If they're really huge, like the robot in the middle that's helping manufacture a Tesla car, it might be a little bit intimidating. All of these are real robots. If it's like the Actroid on the left, we might think that it would be capable of speech because it looks a lot like a human. If it's a robot teddy bear, this is the Sensate bear, which I worked on for my master's thesis a couple years ago at MIT, and it actually had teddy bear skin. It might be your favorite gift to buy this upcoming holiday season. But there are a lot of ways that we interpret things from machines beyond just its physical appearance. As soon as you make something move, that communicates different things about its state. There's things about body pose. There's facial expression if a machine has a face. And even if it doesn't have a face, we tend to ascribe a head to some part of its motion. If it's a robotic arm, we might think its end effector is the face. If it then changes and there's a sensor spinning, we might then ascribe that to be the face. But what I look at is, right now, I'm looking at is quality of motion and machine gesture for non-anthropomorphic robots. And guess what? That includes drones. In my other hat, I also run a robot film festival. I'm showing you this video from this year's festival in San Francisco of robots that don't look like people, but they are definitely communicating some sort of interaction and conflict. Just another pancake breakfast. So obviously that's using lights in addition to motion, but the channel of motion alone can communicate quite a lot. There are some interesting studies that have already been done using, for example, how a Roomba traverses a floor, but some of my favorites are much simpler. There was a Stanford experiment that had someone Wizard of Oz, which means a human puppeteers, a single-access automatic door. So, for example, someone might come up to the door, it opened a little bit, they get a little bit closer, and it slams shut. People honestly thought that the machine was judging them and didn't want them to enter. There's been another experiment with a motive stick. It did a lot of different kinds of things. If it had regular motion, people thought perhaps it was a machine, not an agent. If it had erratic motion, perhaps it was angry. There was one person in a Wizard of Oz scenario that came into the room, laid down on the carpet, so the stick lay down. And then after his 5 minutes was up, he waved goodbye, the stick waved, and left the room. So he reported that he took a nap with the stick, and then they said goodbye. So it doesn't take a lot to be able to communicate with people. We are naturally social. Where does this come from? How do we interpret motion? And when do we make these kinds of social attributions to machines? One of the earliest experiments looking into this phenomena was in 1944. So these are just triangles and circles, right? I'll let you watch the video. So simple shapes. Based on the cheering and booing in the audience, I think that most of us here attributed some sort of agency, character to these objects. And so obviously that means we can do that with flying machines too. And it turns out later experiments showed that people that didn't make a story out of that scenario perhaps had brains that weren't fully working. They didn't have full social capabilities. So part of being a healthy human is ascribing character to abstract objects. And what is the key to that ascribing of character? Is goal-directed motion. So think about a falling leaf. If a falling leaf is just following the rules of physics, it's an object. If that falling leaf suddenly sees a butterfly or a drone fly in and starts chasing it, that leaf has suddenly become an agent. And so if we want to create machines that have characters, then we need to think about relational motion to other objects or it having some sort of intent. And it turns out that most robots have some kind of purpose in mind. They're trying to finish a job. And that means that automatically, if they can adapt their path to still achieve that objective in the face of conflict, then we are going to think of them as characters. And we can use this to design machines. So my current research is using a robot at CMU called the CoBot. I don't know if Professor Manuela Veloso is here, but I know she was stopping by the conference. It's her lab that's created it. I know it's a mobile robot with an omnidirectional base, so I'll get back to the drones in a second. But I ran a recent study having people act out motions that they thought the robot should do to communicate particular states. And we found some of the trajectories to the right. So for example, if a robot is failing at achieving something and it's getting really frustrated but it's in your way, you might feel a lot more forgiving of that if you can tell that it's sad and disappointed that it's not working. And when it suddenly finally gets through that door that's blocking you from getting to the coffee machine and is really happy, you will sympathize with it and not want to break it, for example. There are other situations in when you would want to know when the robot is exposed to a novel phenomena, or for example, it could express some shy or is confidently moving through a room. You might also want to know whether it's a good time to stop that robot and ask it to help you out with something or show you where something is, versus it's in a rush and you can't interrupt it in that moment. I liked taking inspiration from theater and entertainment. There was a really cool play done by University of Texas called A Midsummer Night's Dream with Robots, where they had little drones be some of the fairies. And they didn't really work that well. They were piloted locally, but they often fell into the audience throughout the performance. And so people not having been exposed to many drones in that particular audience, because they didn't advertise they were being robots, so it wasn't just robot enthusiasts in the audience, the first thing they would do is they would pick up the drone and they would like frisbee it, thinking that it would magically start flying. And that ended up in some broken robots. And eventually, through iteration, through performing multiple times, they realized if the drones fell down on stage and an actor went down and gently left it off into the stage, they gave it the character of kind of like a baby robot that was learning how to fly. As long as the audience had seen the actors do this, when it went into the audience, they would gently pass it down the aisle to one of the ushers, or gently put it in their hands so it could fly back up to the stage. So we can learn how to treat robots by watching other people. But it is important to make some of these character attributions because it changes the way people will frisbee or behave with your machines. So and there's a difference between detecting a particular type of emotive motion and being able to create it. One thinker that's used by a lot of roboticists is Laban Motion. And it's a school of thought about motion that looks at space, weight, timing, and flow. There was a paper at last year's Human-Robot Interaction Conference that looked at creating some of these pathways, and they brought research subjects in to say what they actually felt about the different pathways. So pathways that were very direct and just kind of from one goal to the other were seen as methodical, machine-like. Ones that were slow, the robot might be sad or disappointed. Ones that are meandering, there's a lot more emotion. So you can add emotion to the path of your machine just by making it a little bit indirect. And you can play with tempo to express different types of state. So I challenge you to design scenarios to make videos about flying robots that are in human environments, not causing harm, but that are creating a story. So make something like that circle and triangle video. Submit it to my film festival. We'll show it to lots of audiences. And I think it's just a different way of thinking about what we can do with flying machines. I'll have one video after this. So the big idea is that, yes, we judge machines. And yes, we judge them along the same lines that we look at human or machine motion. And I challenge you to use this knowledge to design better machines. So local dance troupe, Pilobolus, and MIT's Distributed Robotics Laboratory collaborated on a theater production that traveled through the US, but started here, that features a single dancer and a drone. Think about some of these categories of motion, or what is it that's communicating? Thank you.
Nope, nope.
Oh, such a sad sound.